Hello and welcome back. Today we'll be doing a question from the Oxford Engineering Science Induction Pack at the Oxford University Department of Engineering website. Let's get started. Part A. Find the resistance RAB between A and B in the circuit below. Hint. Redraw the circuit combining the series and parallel components. You need not do this in one step. Part B. Find the current I in the circuit below. Part D. For the circuit shown below, choose R1 and R2 so that the voltage V is 10 volts when the device A draws 0 current, but falls to 8 volts when I rises to 1 milliamp. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. Firstly, we'll look at the 4 ohm and 2 ohm resistors here on the right, and we'll add them simply in the series to get a 6 ohm resistor. Next, we'll look at the 3 ohm resistor in parallel with the 6 ohm resistor. Here, the total resistance is going to be 1 over 3 plus 1 over 6, all to the power of -1, which is equal to 2, and therefore this here will be 2 ohms. Similarly, we'll notice that over here we also have a 3 ohm resistor in parallel with a 6 ohm resistor, and that will give us 2 ohms of resistance. Finally, we'll notice that we have 2 ohms in parallel with 2 ohms, and when we add them together, we get 4 ohms. Now we'll move on to part B. Firstly, we'll notice that on the right hand side, we have in fact completely bypassed that 3 ohm resistor with a short circuit, and therefore this section has a total resistance of 0 ohms. In total, this circuit therefore has a total resistance of 30 ohms. Next, we'll look at this cell drawn in. The right-hand side of this cell with the long line is the positive side, and therefore we have a total of 90 ohms in the direction shown by the arrow. Therefore, we can calculate the current as 90 volts divided by 30 ohms, which gives a current of 3 amperes. Now we'll move on to part D. Firstly, we'll look at the case where the current is 0 and the voltage is 10. This implies that R2 over R2 plus R1 is equal to 10 over 15, and this can be solved to give R2 is equal to 2 of R1. Now we'll move on to the second case, where I is equal to 1 milliamp and V is equal to 8 volts. Firstly, we'll define R2 to be the sum of resistances of component A, which right now has a resistance of 8 kilo ohms, and also R2. Using the same method as above, this will have a resistance of 8 over 7 of R1. We can now rearrange into this form here, and then substitute 2R1 for every single R2 before cancelling, and then arriving at the equation 112 kilo ohms over 16R1 plus 64 kilo ohms is equal to 1. From here, it's then relatively easy to solve for R1, which is equal to 3 kilo ohms, and therefore R2 is equal to 6 kilo ohms. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.